used to work in the lab, and I ran clinical tests. Like the rapid test it's really not that accurate, so we always do a confirmation test that would take anywhere from a day to a week. So I assume that's what they're doing still, but yeah, I don't know.
Is that both different than the lung piercing kits?
Yeah.
You ever check out the Z statistics? He does a lot of health statistics.
Huh. No, I haven't looked at that one. That would be cool.
ZED statistics.
That's easy to remember. That's my initials.
Yeah. He does a lot of health IQ.
Oh, nice. Yeah, we got everybody. We got one person out. I don't know what we got online. Okay, so I will. Hopefully, this lecture only take like half an hour, and then we can do some other activities and whatnot. I feel kind of like I guess remember when O2 bars were popular? It's like the opposite. Like you're wearing the mask, and then you go to your office, take it off, and you can breathe for 10 minutes. Anyway, so we're going to start with chapter 1. So my first question is, what is statistics? So on the screen, statistics is the science of data. It involves collecting, classifying, summarizing, organizing, analyzing, and interpreting numerical and categorical data. So I think that's actually the answer to your first homework question. So just keep it in mind.
Thank you.
So in statistics, we have two major processes, right? So we can either describe sets of data, or we can try to draw conclusions, which includes making estimates, doing like hypothesis testing, or we can predict or prescribe what we think will happen or what we should do in case that happens. So with descriptive statistics, we will want to collect some data, such as quarterly sales data, which is kind of like what's pictured, and looking at because looking at raw data doesn't generally amount to anything, so we need to do some kind of analysis, some way to summarize that data and present it or visualize that data. That will help us characterize or describe the data in a meaningful way. So if we collected this quarterly sales data, we could use a histogram to examine that sales data for each quarter, and then we could compare them to each other, each of the other quarters, possibly to the average annual sales, and then we can notice that quarter 1 and quarter 2 were below average sales. So what kinds of decisions could we then make based on this data visualization here?
So that's sales, is what that was?
Yeah, so this quarterly sales data.
So I guess you could look at quarter 3, and is there different amount of staffing that's required based on the influx of sales during that period of time?
What do you do differently? Did you change pricing or is there?
Yeah, or maybe it's seasonality. I mean, if it's like the Christmas run, and that's something that some kind of consumer good. But so that's descriptive. On the other hand, we have inferential. If we have a population, we want to make estimates about that population using samples that we can use to do hypothesis tests and determine if our estimates are statistically significant. This is where we're going to get into things like p-values. Have you guys heard of p-values? Less than 0.05 is like the most common one, right? So the 4 elements of just a descriptive statistical problem is we have a population or a sample of interest, right? So it's going to be on both sides. We're going to have one or more variables, which are the characteristics of the population or sample units that are to be investigated. Then we're going to have our data visualizations, which will include tables, graphs, or numerical summary tools. It'll be like our mean, median, mode that we're going to talk about in a second. And our goal is going to be identify patterns in the data. 5 elements of statistical problems for inferential. We're going to have, of course, population of interest that we're going to take samples from. It's going to be one or more variables, characteristics of the population that we want to investigate. We're going to take the sample of that population unit. Then we're going to inference about the population based on information contained in that sample. And we're also going to want to do some kind of measure of reliability for that inference. So we'll get into, validity and reliability measures. So there's two primary types of data. We have quantitative data and qualitative data. Quantitative data are measurements that can be recorded on a naturally occurring numerical scale, whereas qualitative data are measurements that cannot be measured on a numerical scale and are generally classified into categories. So examples of quantitative data could be number of defective lots if you're manufacturing, salaries of CEOs at oil companies, or ages of employees at a company. So all things that we can measure numerically, right? On the other hand, qualitative data are ways that we can classify the data or categorize them. So such examples as college major of each student in the class. So some are accounting, finance, etc. Gender of each employee at a company, or method of payment, cash, check, or credit card. Can qualitative data also be numeric, though? If we look at gender as a binomial data point 0, 1, so and those numbers don't actually mean anything numeric, right? But we can still use them, as well as like groups. If you're in group 1 and you're in group 2, those numbers don't actually have any real true value. But you get into another set of numbers called ordinal numbers, which are like, have you ever taken a survey with 1 through 5? Do those values actually have any value? They have ordered value, but they're not, we can't just like add them up, right? When we get to your data. So obtaining data can come from many sources. What kind of data, or where do you guys get your data when you're working with? Probably from
Different tool sets, data warehouse, everything ingested from the data.
Yeah. Well, I worked at IWA Health System as a database analyst. All of the data I worked with came from a data warehouse, so I used SQL to pull it down and do reporting and whatnot. But it can come from published sources, such as books, journals, newspaper, websites. It can be designed experiments. That's typically going to be where a researcher exerts some treatment on different groups. So you'll have like a control group and you'll have your treatment group. You see this more like in agricultural science when you have, plants with fertilizer and non-fertilizer, so you can really attribute to, is that fertilizer helping these plants grow? Or possibly like social science, like employee engagement, by looking at different factors there. Surveys, a group of people are surveyed and their responses are recorded. I know everybody's taking at least one survey, right? If you took a survey from my class, so. But and then observational data, units are observed in their natural setting, and the variables of interest are recorded. I'd probably say that's what most of us use, right? If you're getting the data warehouse, always observational data recorded for you to use. So when we take our samples from the population, we want a representative sample so that the sample exhibits characteristics of the entire population, right? So to do that, we want to do some kind of random sampling. Simple random sample of n experimental units is taken from the population. So every sample of size n has an equal chance of selection. So another thing we can do is something called random number generators. Has anybody heard this term before? It's actually something we can do in Excel. So I have Excel pulled up. It's called the RAND function. So the rand function is Excel's built-in random number generator. And it will give you a random number between 0 and 1. And if you hit, I think it's F9, you can get it to repopulate. So one way we can generate random numbers in software.
Can you give examples of why you would use that instead of like an random function? Like in a scenario that you would generate like
You can build a dice roll. So yeah, that's one I do in another class. You multiply that number by 6, and I think we put the round function in there so it doesn't go over. But
Gotcha. Okay, cool.
so, but when you go into like simulation, which you're going to cover in operations management or a different quantitative class, that's when you would use random number generations. So, try to make a simple example, but yeah, I don't know who teaches the I think Dr. Marabella teaches it, and you'll get into more using Excel for that. But I just wanted to show that it's pretty simple how it's generated. Let's see. Okay, so there's different kinds of random samples. There's stratified random sampling used when the experimental units associated with the population can be separated into 2 or more groups. So can somebody give me an example of how we might stratify a population?
Gender, age.
Gender and age, not bad. An example I usually use is like at the university, we would have freshmen, sophomores, juniors, and seniors. So we would want to sample people in each of those groups so that we get a stratified random sample. Now a cluster sample, so we want to sample a natural grouping of experimental units. And we want to collect data from all experimental units within that cluster. So really, how does stratified random sampling and cluster sampling differ?
The example on cluster sampling that I think was in the book was a chain of restaurants that assesses only few restaurants, but within those restaurants, all the customers are assessed. Whereas the stratification phenomenon will be a sort of separation at the onset of the study. So you branch immediately all the units of the samples into specific categories.
Exactly. So in the stratified, we're going to do a simple random sample inside those stratifier, and then the cluster, we're going to sample everything in that cluster. So we have systematic sampling, which is like every 10th person that walks through the door will get surveyed. Randomized response sampling is useful when we're doing like a survey and we don't want to elicit false answers. So something like if you're doing a survey, particular question order might bias a upcoming question, right? So the reason we want to do these random sampling is we want to reduce our selection or different kinds of bias. So there's selection bias, which results when a subset of the experimental units in the population is excluded. Non-response bias would be anybody who doesn't take the survey. We don't have that representative group in our survey. And then measurement errors refer to inaccuracies in the values of the data recorded. In surveys, the error may be due to ambiguous or leading questions and the interviewer's effect on the respondent. So if we're building a survey, these are things we need to take into account. So the whole goal of this class is to get everybody to think